Okay, so we continue to part 2. This is basically the title under Gantt chart for mortgage service. Okay, just imagine that you are planning to apply for housing loan to purchase a real estate property like a house. So let's take a look on how this process could be executed with this Gantt chart. Okay, the activities here at the column Y is basically representing the activity task for property survey. And the property survey, it takes time execution for 90 minutes. Each survey takes 90 minutes. So there are 3 surveys, 1, 2, and 3. The next activity is the credit report, assessment for the credit historical report. It takes 45 minutes of a time cycle. And the third activity is searching for title. And this task is taking 30 minutes per cycle. And the fourth activity is final approval task. It takes 15 minutes per cycle. So if you take a look on the Y axis here, you have the credit report 45 minutes, which is from this line to this line. And this is the timeline for 90 minutes. And then another, for the second application, there is a second credit report, another 45 minutes. For the third application, there is a third credit assessment report, another 45 minutes. And after finishing credit report, next process is title search. It takes another 30 minutes and 30 minutes so for application 2 and 30 minutes for application 3. And when this property survey has been done for 90 minutes, credit report, title search, and then there is another final stage of approval, it takes about 15 minutes. So this process is a standard mortgage application service in the form of Gantt chart. Respectively, you could refer this diagram at figure 5.5 at page 125 of the textbook. Okay, so next, let's understand the terminology or terms executed under this Gantt chart. CT, which is cycle time, it refers to the average time between completion of successive units. For example, one property survey, so the cycle time is 90 minutes, and then next survey is another 90 minutes, and the next survey is 90 minutes. So total 120 minutes for 3 application. Okay, another term is a bottleneck. Refers to the factors that limits production, usually the slowest operation. If you have a process from A, B, C, D, so the process which is slowest takes longest time to execute is called bottleneck. Okay. Next term is capacity. It refers to measure of output per unit time when the system is fully busy. So in other words, that is the time taken when the system is fully in operation. Next terminology is capacity utilization. It refers to measuring of how much output is actually achieved. Okay. Next, throughput time is refers to the time to complete a process from time of arrival to the time of exit. Okay. In other words, throughput time is the overall time taken from the start until the finish. Okay, so next terminology is rush order, flow time. It refers to the time to go through the time. It refers to the time to go through the system without any queuing time. In other words, this is the most fast or the fastest flow from the start until the end because there is no queuing time. That is rush order flow time. Next terminology in the process analysis is direct labor content. It refers to the actual amount of time consumed, total time consumed to finish the task. Total direct labor content refers to the sum of all the operation times, in which refer to all the times taken to complete the process. Last but not least, the terminology for direct labor utilization, it refers to the measure or percentage of time that the workers are actually contributing value to service. Okay, this is the explanation for the process flow diagram for applying housing loan or mortgage service. Okay, this is the oval. It starts here. So the accept the mortgage application, and then execute the property survey, in which a background check the survey of the property and so on, overall taking 90 minutes. And upon completion of the property survey, then it goes to the next stage, which is final approval. Cycle time is 15 minutes. But prior to that, upon mortgage application, so it goes to the next task to check, which is check the past credit record for the applicant. Cycle time, it takes 45 minutes. And subsequently take the title. Next process is search for the title. Cycle time is 30 minutes. And then completed, it goes here next to the final process. However, if you take a look on the top, the property survey, it takes 90 minutes. The bottom part is credit report and title search. Total, it is taking 75 minutes. So this process is still faster than the property survey. So next, final approval, it takes 15 minutes. If it is approved, then letter of offer will be issued. If no, then subsequently it finished the process. Next. So this is the from the Gantt chart. It is transformed into a product layout process in terms of work allocation for the problem. So this is the in, this is the out. This is another scenario setting explaining for work allocation problem. For example, in the textbook, it is explained for a driver to apply their license application. In Malaysia, it is equivalent to try to get your driving license at JPJ office, okay, Jabatan Pengurutan Jalan. So first activity is review the application. Okay, second task is process and record the payment. Next task number 3 is check for violation, if any past driving record or summons and so on. Next process is number 4, eye test, check for blindness of color, sight viewing and so on. Next task to check is number 5, take the photo and subsequently issue the temporary license, and out you go from JPA office. So in this process, first task, basically review application. So it takes 15 seconds per cycle. Okay, and this is taking 30 seconds per cycle, and this is taking 60 seconds per cycle, and so on. Okay, so this is the capacity per hour, in which for task 1, to review the application for getting the temporary license. The capacity, this is the 240 application capacity per hour. So they have, and also accordingly 120 application capacity per hour. This is they can process 60 application per hour, and subsequently last one 120 application per hour. Okay, out of this 240 to 120, 60, these are all the needed time for the processing. Okay, and the limitation is basically in order to ensure this process flow rate become optimum, the flow rate must be set at minimum 120 application per hour. So the JPJ office must process at least 120 application per hour. This is the minimum, which is bigger than the 120 application. Okay, if the previous layout of the process flow is basically linear from here in, go to out. So how can JPJ officers process more application per hour so that they can have higher productivity? So the option is in this diagram. In order to process more than 120 application per hour, so the JPG office need to do some relayout of the linear process flow from left to right. So basically, from process 1 and 4, they can be combined and then later split into two lines, which previously it has only one line, now it has two lines. So if it combines process 1 and 4, so this basically the cycle time, it takes 55 minutes per application, right? And the capacity is 65 application per hour. So process number 3 basically is referring to check for violation or past traffic record. So you could see that check for previous traffic offense report, which is task number 3. It takes 30 seconds per cycle time. As such, within 1 hour, it can process 60 application. So the minimum limitation 120 application power is still met, because 60 and 60 for two line, they still can execute processing for 120 application of temporary driving license. So after that, it merged into task number 2. Task number 2 is basically referring to process and record payment. Okay, process and record payment, it takes 30 seconds per cycle, and as such, it can process 120 applications per hour. Okay, so this later move on to task number 5, which refers to taking the photo of the applicant. Okay, taking photo, it takes 20 seconds per cycle, and as such, for 1 hour, it can process 100 application, 180 application. Subsequently, task number 6, which is basically referring to issuing the temporary license. So it takes 30 seconds to issue per cycle, and as such, 120 applicants can be processed to issue temporary license. Then complete, out you go. So this is another layout that the JPG office could improve in terms of the process flow. So however, it needs 6 employee, 1, 2, 3, 4, 5, 6, 7. So in this process, it needs 7 employees. Whereas in the previous process flow, it has only 6 employees. So in order to have this double line at the starting of the process, JPJ must buy another eye testing machine. So over here, right? Another eye testing machine, and also another uh, eye tester or check violation process, which is at this one for another employee here. So this is one way of executing the process flow rate for the task for minimum 120 applicants per hour. There are another improved layout that you could execute it even faster, but with other rearrangement of the process flow. For example, this is another process flow arrangement in which they open as many as 6 counter for in to process the task from 1 to 5, okay, in such a number that for every cycle time, it can be processes as 165 seconds per cycle, and as such, it can process 22 applicants per hour. So as such, you have 6 lines here from process 1 to 5, and subsequently all merge into task number 6, which is issuance of the temporary license. It can issue license as fast as 30 seconds per cycle, and as such, total per hour 120 applicants of a license can be processed. However, to have this kind of arrangement, so the JPJ office or DMV office or Department of Motor Vehicle must add few other resources. For example, buy some more computers to be installed here, buy 5 more eye testers to be installed here, and also buy another camera to take photos of the applicant to be installed here. So as such, in overall, per hour they can process 22 customers within 1 hour. So that is one way how to improve the process flow. So another way of doing the same task, but with a different process flow. Okay, among the last example that is explained in the textbook is the layout of a process at the theme park. It is a kind of attraction park in which, in this kind of theme park, it has attraction for killer whale at the station A. It has the attraction of sea lions at this station B. It has the attraction for dolphins at station C. It has the offering of water skiing at station D. It has attraction for aquarium at station E, and it has the attraction of water recreation park at station F. So you have this kind of layout: A, B, C, D, E, and F. Okay, this is one location at the western part of the United States. They want to open another park at the eastern part of the United States. So previously it is arranged the station as A, D, B, E, and C, F, as shown in figure 5.8a. Now, based on that process flow, based on the previous process flow, they have this kind of arrangement for the Ocean World Theme Park, right? From moving from A to B, it takes 8 meters. So moving from C to A, it takes 10 meters. Moving from D to A, it is a short distance. It is just nearby, and so on. So if you have to design the process layout into a new place, so based on this arrangement, right? What could be the option that you could have a optimum people flow in that theme park? So it could be arranged in this way, in the triangularized matrix. Okay. So let's take a look on the arrangement. If the previous arrangement is A, D, B, E, C, F, so it means that from A to C, so it is 30 meter times 2, it means 60 meters. From A to F, it is 6 meter times 2, because this is a go and for direction. You go and later you come back. That means 12 meters, and so on. So in the overall, in this kind of arrangement, it is making 124 units of flow distances, 124 units. So if this flow is supposed to be optimized, we could see that we have the option B, which is move C close to A, like this. C, you got to move it closer to A, so that the travel distance will become from 60, it will become to only become 40 meters here. So if you move a C to here, it will become like this, which is C is here, A, B, D, E, F. So as such, moving from C to D, okay, it takes only 40 meters. Moving from C to F, it takes only 16 meters, and so on. So in the overall distance going back and forth, Total movement of distance takes 65 unit. Okay, if you exchange A and C, okay, A and C, you exchange these two. So now A at the top, C at the bottom. So the calculation of the movement forth and go back. So basically from A, for example, from A to E, now it is only 30 meters. From C to F, the total movement C to F, it becomes 16 meters. In calculation of overall from going back and coming back, it is total up to 70 units of movement. So 124 go to 96 and 70. And at last, if you still can minimize the movement inside the park, if you exchange B and E, so B you exchange with E, in which now E at the top, B at the bottom, like this, E at the top, B at the bottom, and move F. F, this one, move, go up, right, like this, F going up. So in the overall combination of the calculation of distance going forth and coming back, it is like A to B, it is measured at 15 times 2, which is 30 meters. A to D, well, basically it is already neighboring, so it doesn't take any distance and so on. So total up is 58. So from the layout of like this, A, B, A, D, B, E, C, F, now you have a newly proposed layout, which is A, F, C, E, and D, B. So it minimizes the number of movement inside the park so that it is less congested, less jammed. So the new proposed process layout at the new theme park is suggested like this, which is D, B, C, E, A, F, respectively, with the previous arrangement like this, which is A, F, C, E, D, B. Okay, A, F, C, E, D, B. So this kind of layout is basically measured that the total distance to move back and forth here to here and here to here is very minimum, which is 50 unit of movement. So this is the best layout for the total floor distance for the new park that the company need to set up in the eastern part of the United States. So that is how it works. So the final, this is the final and optimum layout that can be achieved by the theme park. Okay, guys and girls, that is my explanation for this part number 2 for chapter 5 of the service management class. So I hope you have benefited and understand my lecture. At the same time, you are expected also to read the text in the textbook. So I would like to thank you for your time, participation, and patience in following through my lecture. That's all from me this time. Thank you and goodbye.